So, warmly welcome on the presentation, or rather talk, with live coding, JVM Toolbox 2017, choose the right JVM language for the right task. My name is Jonatan Kaźmierczak. I work as a senior consultant for Trivadis in Switzerland with nice views, which you can see on the pictures. From the maybe interesting information is I'm creator of Class Visualizer, helpful tool for Java developers. Anybody knows Class Visualizer? Maybe you can raise your hand. Okay, didn't come yet. Ah, you know. Okay, so one person, at least one person knows. Great. From other interesting maybe things is that I have some achievements on HackerRank. I'm first rank in Java plus few other nice things. Okay, what are we going to talk about? The main part of this talk will be live coding. This part we will have 3 tasks which we have to solve. So let's start with introduction. What tools are we going to consider in this talk? Java 9, first of all, was supposed to be already here, but there is some shift, so probably the talk will be should be rather now JVM Toolbox 2018, will be more relevant, but yeah, we have it already. Scala, Groovy, and JavaScript, and by JavaScript you understand ECMAScript 2015 running on NASCOR, which is in Java 9. When we are talking about those different languages, those tools are representing them, but we actually want to have something more convenient, more portable, something like Swiss Army knife, and we can actually combine those languages into the Swiss Army knife with help of Gradle. But you may ask, why at all should I use more than one language? Or we can say the same about the tools. Yes, my knife is perfect. I can do everything with it. That may be true. Yes, unless you get a bottle of good red Swiss wine, and you try to open it. Yes, you take your knife, and yes, I don't know how it will end. But probably rather you will take a dedicated tool for that task, right, the wine opener. And going further, carrying all of those 4 tools would be inconvenient. They are big, and maybe you don't need them always. So much more convenient is to have a Swiss Army knife. And you can use your knife most of the time, but on demand, when you need, you just open another tool, the wine opener, and you do your task in a very convenient way. And exactly the same is with programming languages. Now, team, we are talking about the tools, but of course, people are important, right? We have Scrum team, product owner, Scrum master, and 4 developers. Yes, Java, Scala, Groovy, JavaScript. I believe that you represent each of those groups, which is great. So let's move to the tasks, to the concretes. Before we start dealing with the tasks, I already ran a couple of my favorite IDEs, including JShell, which is a nice addition or nice feature available since Java 9. Then we have Scala, of course, running on Java 9. Then Groovy, the same. And JavaScript shell. And just as additional comment, I needed to add this parameter in order for JavaScript shell to understand ECMAScript 6 syntax. So everything is prepared. Let's move back to the tasks. First task. We need a function returning result of multiplication of 2 numerical values. Sounds very simple, but let's think for a moment. What does it mean? What can be a surprises or tricks here? So first of all, we can expect any numbers, right? Small, big, everything. Also integral, decimal, totally everything. Okay, keeping that in mind, we can start our coding. In Java, I would choose a type big decimal for that. It suits for everything. Now we have auto-completion here. Moreover, I can even see documentation. If I don't remember what exactly is this big decimal about, then I can go through the documentation and read everything. Great. Actually, I will make now a little bit more space, the cleanup of the screen. So let's move with our big decimal. Function will be called mul, multiplication. Two numbers. What type is the SUI table type for the numbers? Probably number, yes, which is the parent of all numbers in Java. So we have already proper types. And now we have to convert our types to big decimal, our numbers to big decimals. And now when I'm thinking about the SUI table constructor, I have sort of problem, because big decimal has many useful constructors. You can create a big decimal from nearly any number except the number itself. OK, so I have to already use some workaround. I can probably convert my number to string and then create big decimal from the string, and it will work. Good, problem solved. Then multiply, and the same way I have to create another big decimal. I already forgot something. I forgot that I'm in Java, and the parentheses are very important. OK, and when we look into the code, you can notice that the solution is not very short. I want just to multiply two numbers, but I already wrote long code. And in normal life, you probably have more mathematical operations than just multiplication of two numbers. And if you see that, then it's a hard job to understand what really author wanted to achieve with those crazy syntaxes and method invocations. So it's not really obvious what is behind, right? And considering the fact that most people don't write any comments, it's a write-only code. Good. How do we handle the same thing in Scala? Here I say that my A is, by the way, I also have auto-completion here. A is big decimal and B as well. And why can I write it like that? I may get any number, but in Scala, compiler applies implicit conversions to my numbers and converts them to a proper type, in this case to big decimal. And I type just A multiplied by B. I'm done. I have a result here. Scala discovered that since those are big decimals, then the return type will be also big decimal, but this is different big decimal than in Java. Just a quick question. Can colleagues in the last rows see well what is on the screen? Can you see well? OK, great. That's important. Now, in Groovy, we have the same types as in Java. We use exactly the same number types. And here, I say as follows. Big decimal 1, which means definitely it's big decimal, no doubt. And I just multiply it by A and by B. And it's OK. And now the question is, why can I do it like that? And will it work? The nice thing about Groovy is that it will take the type of this value, then knows already that, OK, big decimal means we have to convert everything to big decimal. Then takes this value at runtime, determines its type, converts it to big decimal, and invokes applicable method, and so on. So at the end, we have the same methods executed as in Java, but we can do our business job. We don't need to write glue code. Okay, and now in JavaScript, we just say A and B. And return A multiplied by B. Okay, we are done. So, it would be good to test our solution. Okay. So, we have a couple of test cases for this. 4 multiplied by 0.25, 1 in Java, 1 in Scala, 1 in Groovy, and in JavaScript the same. Good. Let's see now into some more advanced test case. I have 2 longs. And in Java we have proper result, but please pay attention to the number 1 at the end. Means, yeah, that convinces me that the value is most likely correct without counting all the zeros. Now Scala, what happened here? Where is my 1? I don't see it. So we are going here already to the losing of precision. And the thing is that in Scala, the big decimal is 128 bits double, which can hold up to 34 digits, and here we have more. So, yes, please be aware of that if in case of calculations in Scala. Groovy. In Groovy, why at all I should put this L? It's a rubbish. I have numbers, not some letters. And Groovy knows what is the type applicable for the numbers and does the calculation. But moreover, I can add more zeros and make it the number bigger. And still, Groovy determines that this is a big integer and compiles it that way. So everything works. Now, JavaScript. Okay, here we even lost more precision. Yes, here we have a 34-bit double. That's the number in JavaScript, and yeah, up to 15 digits. Good. We are done with first task. But what about performance? Okay, Java is the fastest, regardless of the workarounds, which we did. Groovy is 2 times slower. And then, a little bit surprisingly, maybe, that Scala is 4 times slower than Java. Why? It's compiled, everything is determined at the compile time, but it's significantly slower. And then JavaScript, yes, is way, way slower. Of course, all of those statistics are collected on Java 9. And I noticed that on Java 8, results are slightly different. OK, let's move forward. JSON processing. Yes, function which takes specified JSON with list of countries and returns list containing the values of the name property, and that's what we really want to achieve. Yes, we have a list of countries, and that's what we expect as a result. OK, let's try to handle that. In Java, when I think about functionality for processing of JSON in Java standard library, I cannot find anything. Oh, it's a little bit surprising. So when I'm coding in Java, now I have to start to do research which library will be suitable for my task, which seems to be still very complex in Java. In Scala, we can do that. Have to import a proper class for that task. And then I can do my task. CNames, which is shortcut for country names. JSON of type string. I don't need to define the return type explicitly, but I want to make sure that I don't do any mistake afterwards, so I want the type to be enforced already. And then the solution, say JSON parse full my JSON. It gives me optional, so I have to get the value from inside, so get. And what can I do with the value now? Not much. Here are my my methods, which I can invoke. Yes, probably the only reasonable one will be as instance of, this one. And the reason for that is that I have a type any, which is equivalent to object in Java. So now I have to do some conversions already. And now I say, what is in my JSON? OK, I have a list. And the list contains maps, maps of properties with the names and values. So name is string, and the value is any, because we may have anything. OK, so with this converted type, I can do already something useful. I can start to map it. And I take my country, and I say, OK, I want now to have the name of the country. But that's not enough. The result is of type any. Then I have to say, no, convert it to string. OK, I can use, again, this as instance of, or I can say to string. And now compiler is happy, and yes, my code is accepted. While we have in mind this solution, let's jump to JavaScript now. And let's do the same, or equivalent, yes, solution. Country names, my JSON, return, and I say JSON, parse, my JSON. Then I say map. I know what I have, that I have a list, or which is called array. And I say, OK, map my country to the name. That's it. I'm done. So when we look into this solution in JavaScript, it's very similar to the one from Scala, right? Pretty similar syntax. But it's much shorter and easier to understand. It's clear, pretty much clear what is going on here. While in Scala 1, we have to deal with the types, conversions, and so on. And what about Groovy? We have also a dedicated class for that task. OK. So we can start to code. The result is list of strings. And here is our JSON. And what next? OK, let's create an instance of JSON slurper. Then parse text, our JSON. And now I say collect, which is equivalent to map on to previous solutions. My C, I want to map to C.name, my country name. Accepted. I'm in the bytecode now. I mean, the result of this code is a bytecode. And the question is how I can achieve that. How is it that I can invoke this collect on something which, from JVM point of view, we don't know what is that. So Groovy checks the type at runtime. If it's something what is iterable, and in this case, it is. So, OK, method collect can be applied, and then takes an object and invokes this code. But this code, this just c.name may have few meanings. It may be a property of the object, property called name, or, as it is in our case, can be a value from the map. So it can be interpreted in two ways. So Groovy decides, checks at runtime what really is the type of this, applies proper conversions if needed, and does the job. So at the end, we don't need to worry about those details. Now, the question is, how does it work? I have some JSON example. OK, here in Scala, I can use triple double quotes to quote my string. And then, as you can see, I can use my double quotes, and I don't need to do any masking like in Java or such unnecessary things. And everything works. I have my two countries. Good. How is it in case of Groovy? The same syntax works as well. In Groovy, I can also use alternative syntax. I can use single quotes, or I can mix single and double quotes. They are slightly different, but in this case, for our purposes, they have the same meaning. And we have the good result. Good. Now, in case of JavaScript, the same JSON, processed, good. OK, but the question is now, what about the performance? Do you see any surprise here? Yeah, for me, there were a couple of surprises. First of all, which one is the fastest? It's Groovy. How is it possible? It's dynamic. It does so many determination at runtime. But still, for JSON processing, it's the fastest. For Java, I choose JSON-P, which is part of Java EE7, so sort of standard, close to standard, 50% slower. Also, all the types are already statically determined at compile time. Then JavaScript, with all the dynamism, is 2 times slower than Groovy, which I think is not bad. It's good. But what about Scala? Yes. Here we have really a performance sort of issue. Good. So let's see with the third problem. How is it going? We need a function returning defined email template filled in with provided data. Both the text as well as the data must be easy to change and or to extend. And here is our email template. We have several placeholders. And we can start to code the solution. I prepared actually the code snippets already. And we can now use them. In case of JShell, we have some limitation caused by the tool. The limitation is I can copy only 2 lines of text. I don't know what is the reason of this feature, but yes, sometimes it's a little bit limiting. Let's take a look. What are we doing here? String format is standard, available in Java. And then a couple of placeholders. We have some %s, %n, or like here, maybe it's not easy to distinguish which one is which one. But we have those things, and then we pass values of from the map. Good. What happens if we have more placeholders which we want to pass? The solution is not really readable nor maintainable. Which placeholder refers to which value, and also this %n, which is a new line to distinguish from %s, which is string. Sometimes it's not very straightforward, but OK, method is created. Good. At least compiler likes it. Now, in case of Scala, let's use the definition. So header looks similar. Yes, we have a map, string to string. But the way how we are dealing with the text template is already different. We start with S and 3 double quotes. Then we can embed here expressions. So here we already can see what is really going to this particular place. And so on. We have three places. And method accepted. Now, in Groovy, the same thing. I would say quite similar to the one from Scala. Triple double quotes, maybe except some S. We can also mask a new line here, and that's how we can embed our values. I would say it's quite readable, right, what we have here. Okay, and then JavaScript. In JavaScript, I would prefer to have the solution like this, which is it's not really much visible, but let's see if I can make the screen a little bit bigger. Yeah, we are talking about this particular function. Also, maybe it's not so visible on the screen. With, yes, multi-lines, the same way as we did it in 2 previous languages. But unfortunately, current JavaScript shell doesn't allow me for that because I have to fit everything into 2 lines. So I'm doing that. And yeah, so normally I would use the new lines here, but yeah, I'm packing everything into 2 lines. But that's the way how I'm embedding my expressions. And yeah, I'm starting my string with the backtick. Okay, so I can define my template, and it's accepted at least by the engine. So now let's see how those implementations will work. In Java first. Okay, in Java 9, I can use a factory method to create a map. Yes, finally, I can create a map in 1 expression. Wow, I waited 20 years for that. But if you see those values in 1 line and you take 2 neighbors, then, and we have a longer list, then I start to ask myself, is it my key and my value, or I'm taking a value from something else already and my key? It's not very obvious anymore. So still some room for improvement. But works correctly. Good. We have the values replaced. Now Scala. In Scala, the syntax is quite similar with the map. And here, we can notice that we have a clear indication what is a key and what is a value. OK. That's good. Works good. We have here, yes, Harley Quinn. Good. Now, Groovy. The map in Groovy we create in the simple way, just with square bracket. And we just say, OK, key and value. Very simple. No overhead. And the result is here. Yes, the first value is replaced. But if we are looking carefully, and I know that you look carefully, we see something is missing here. We had an empty line, but it's not there. Yeah, so It's a feature which I don't understand, but for some reasons in this triple double quotes, somehow something happens with the new lines. Anyway, Groovy, on the other hand, has many text templating functionalities which can be used instead of that one. But, yeah.
What happens if you use triple single quotes?
Sorry, if I use...
Triple single quotes.
What happens if I use yes, that's the question.
That still feels...
If I will use triple single quotes, then this one will be treated as text. So yeah, we have to use double quotes. That's the difference, actually, because it's very good. We have already first question. Maybe not planned at that time, but it's very good. Yes, what is the difference between single and double quotes in Groovy? Double quotes are special strings. They are not strings, they are G strings. And they are doing this replacements during evaluation of the string. Good. And then JavaScript. Okay, and the values are replaced as expected. From maybe some additional interesting detail about Groovy and JavaScript, those two languages or engines can be used for dynamic evaluation of expressions at runtime. So we can use them, for example, for calculators or for processing of the text. So that's quite convenient. Good. So the task is done, but what about the performance? Any surprise here? Yes. Which one is the fastest? Groovy. Interesting. So many things determined at runtime, and turns out to be the fastest. And then Scala and Java, both of them have to determine everything at the compile time, and they are 3 times slower than Groovy. And JavaScript, yes, no comment. I'm sure we will not use it for text processing. Templating. Good. We have 3 solutions in 4 different languages. Let's combine them together. We want to combine them with Gradle. And that's the way how we structure a Gradle project with the build definition, and then we have a dedicated directories for each language. And JavaScript goes to the generic one, to resources. If we have such build, everything looks okay, but there is some detail. We have some issue on Gradle, and this issue is related to the fact that Gradle actually crashes on Java 9. Maybe I can actually demonstrate the behaviors of Gradle. I don't have it on my path, so Gradle 4 is just released. Let's say test and stack trace. Ooh. Yes, that's how it behaves now on Java 9. So yes, our Gradle colleagues still have some time to make it working on Java 9, and I'm pretty sure they will be on time. They still have some time. Great. But let's move now to the build definition, to the build Gradle file. How we make our Swiss Army knife. If you use Maven, by the way, who is using Gradle? Maybe you can raise your hand. Okay, is good representation of Gradle users. And who is mainly using Maven? Okay, I would say the proportions are actually quite good for Gradle. The Gradle colleagues would be happy. But anyway, more people are using Maven. And of course, in Maven, it's not an easy task to plug several languages. But in Groovy, many of you know it, of course, since we are using Gradle. We can apply plugin Java, Groovy, Scala. We are done. Plus, define dependencies. And if you decide to use Groovy, then please always remember about small detail, this in the classifier. It gives you a version of Groovy which is compiled with use of invoke dynamic. And that's the one which we are using here. And there is a difference in performance in case if you decide to not include this indie. And then Scala. And yes, we are using always the newest version here for Groovy and Scala. Good. So let's summarize now. Languages, flexibility versus safety. How does it look? So here we see flexibility. Java, minimum flexibility. And on the other hand, JavaScript, you can do absolutely everything. It allows you to do even more than you want. On the other hand, we can see that safety is really opposite to the flexibility. We can come to those diagrams and other things during questions. We will have enough time for questions. So if you will have additional questions, then we can discuss those things in more details. Then interoperability. That's another topic. Yes, how those 2 or 3 languages will work all together. Java and Groovy, no problem. Full interoperability in both ways. But if we want to use, for example, Scala or JavaScript from Java, then we already have some differences in types, and we have to handle them. And actually, this path, so using those 4 languages from Java, is the one which I used in the source code, which is available there on GitHub. So I think it's the most difficult anyway, most difficult path, but it's the one which I choose. Good. And of course, now we have quite significant list of pros and cons of each of the languages. I will quickly jump to next slide, and we'll bring that back. You will have time to read those information. Because now is generally time for questions. Feel free to ask about everything. OK, can we get a microphone somehow? I will need to go. OK. Here you are. With microphone, can be more helpful for.
So how have you measured those times?
OK. Seems the microphone is not yet on. I'm not a microphone specialist.
OK, so the question was, how have you measured those times?
Yes, thank you. It's a good question. Let me show it. I wrote a unit test, and we will now open the relevant file. OK, that's the file. I'm thinking if, I'm not sure if I can make it bigger, but to give you some insights into that, yes, here is the stopwatch, which is measuring the time, because actually I need nanoseconds. Milliseconds were not enough. And then, of course, it may behave totally different with each language if the classes are not loaded. So I have to ensure that all the classes are loaded, all the methods are resolved, and so on, and including the fact that the JavaScript engine is created and initialized, like here. So first I do initialization, then warm up. And warm up actually goes through all the functionalities which I want to test and make sure that everything is in place. So then the test cases are really going on. Does it answer your question, or you would like to add something? OK, good, thanks. OK, please, next question. We have a good couple of questions, 2 hands. By the way, the time, we have still around like 10 minutes, right? Correct. So we have enough time for questions. So I saw hand here and hand here. Okay, let's start from this side.
Thanks. Thank you for the talk. Okay, so the question concerns the example with parsing JSON in Scala. Did you try to use other JSON parsing library? Because the library which is in the standard Scala library, it's very slow. There is a library which is called Sarsi, and it's really efficient. Did you try that one?
Once again, what is the library which you mentioned?
Sarsi. It works in such a way that it is generating the serializer and deserializer during the compile time. Mm-hmm. So during the runtime, it's really fast.
Okay, so the goal of this task was to achieve everything with the standard language functionalities.
Okay.
So, of course, they are different choices, different libraries, and thank you very much for the point. So yes, nobody will use definitely this functionality, I guess, but it was to show what is really available in the language and compare those language features. Of course, we have plenty of libraries, but that was not the focus of the task. Does it answer your question?
Yeah, thank you very much.
Okay. Yeah, so yes, thank you for passing to other colleague.
My question is, either anything, JavaScript is better than Java or Groovy in?
Okay, if there is a task in which JavaScript is better than the other languages.
Yeah.
I would say that maybe not better, but from my point of view, is comparable. I mean, it's not my point of view, it's the result of statistics. Comparable with Groovy and Java for JSON processing.
Actually, I was expecting that it will be the best one in JSON processing. I was a bit surprised.
Sorry, I didn't get
I was a bit surprised that JavaScript was not best in JSON processing.
Mm-hmm. Yes, and I guess that it's good actually, because I say there may be a couple of surprises, so it's good that the results surprised you. The thing for that, I guess, maybe that JavaScript is, the JavaScript code is transformed into bytecode by Nashorn engine, actually every time when the method is executed. So in other cases, after this warm-up, everything was already resolved. But here, after next run, Nashorn needed to generate a bytecode again. And this is this overhead, which I would say is really very small in case of JavaScript, but in other cases, as you saw, it's very significant. So I would say for this particular case, JavaScript is suitable from the easiness and performance point of view.
Thank you.
Next questions. We have a question. Could you please pass the microphone there? Yeah, we are IT specialists, not microphone specialists. So.
Okay, now.
Now works?
So on the one table with comparison, there was column safety. What do you mean as safety? It's about this problem with accuracy with multiplying big integers, or what do you think? What do you mean as safety on this?
Sorry, I didn't get you well. I have a small request because there is very big echo. Could you please come to the first row? You will ask the question again, and I will hear actually your voice without the echo from the speakers.
Okay, the question is, what do you mean as safety on this comparison table? Safety is about the problem with the accuracy when you multiply big integers, or what do you mean as safety?
Aha, okay. Yeah, it's a good question. Safety.
The previous.
You refer to this one,
yes.
I guess. Yes. So safety has actually many phases. On one side, you have a type safety, which I would say this is often what comes first time, on the beginning to the mind. Okay, type safe, then good. But that's not the only safety which we have. We have, for example, safety of generated code. So is the code, can the code be safely executed on any Java, any JVM, or we have some strange hacks which stop to work after migration, for example, from Java 7 to Java 8. And that was the case actually with Scala. Scala was crashing on Java 8 with the previous versions. Of course, I cannot blame any of the languages. I mean, I cannot blame that early or previous version of Scala was crashing on Java 9 because nearly everything is crashing on Java 9. But that's the other aspect. Then the safety includes also the safety from making mistakes. And it's not only during coding, because we have everything in our mind well already organized. So we can write, for example, the multiplication in Java or mathematical operations, but it's not safe when somebody has to maintain the code afterwards. So they are at least those aspects of the safety. Does it answer your question? Okay, you're welcome. Next questions? No questions. Ah, there is. Here you are. Yes, please take the microphone, and it's on your right hand. Thank you. And I'm coming closer to you to hear you well. Okay, yeah. We are good testers of microphone. Okay, I will repeat it. Mm-hmm. What is the reason? Okay, so the question is, what is the reason, in my opinion, what is the reason of good performance of Groovy? I know that there was a Groovy committer here, but I don't see him here on the... but anyway, he was here present. He could probably answer the question the best. But I will say what I think. Yes, please don't treat it as 100% absolute truth. So one thing why Groovy is good, doesn't mean it's the best, but it's good, is the fact that the code is compiled with invoke dynamic. And this gives a significant difference in performance of Groovy itself. So always invoke dynamic version. Then there is another thing which surprised me, and I can disclose it now. Is that the results of the performance results were different on Java 8 and are different on Java 9. And Groovy actually, what surprises me, doesn't differ. Very similar results on Java 8 and Java 9, while Java itself and Scala is significantly slower on Java 9 as comparing to Java 8. So in Java 8, if you get the code from the GitHub and you run it, the results are slightly different because, yes, to build it, you need Java 8. But on Java 9, I don't know what is the reason behind, but Groovy is performing, I would say, very well. But I don't know 100% what can be the reason of that. I'm sure, however, that the people who are working on that have a good ideas behind. So does it answer your question? Okay, good. Do we have any other question? Or you would like maybe to see something what was not shown, like JSON processing in Java, for example? I didn't show it. We still have, no, my time is finishing. But if you have last question, quick question, we can make it. We don't have any questions. It means that we can finish, and I wanted to thank you very much.